Welcome to podcast number 249. This is going to be a podcast that will show you the concept of takt planning. Stay with us.
This is the Elevate Construction Podcast, delivering remarkable content for workers, leaders, and companies in construction wanting to take their next step. Get ready to step out of your comfort zone with Jason Schroeder as he encourages you to do better, live a remarkable life, and expect more. Let's go.
Welcome, everybody. I hope you are ready for the third installment of the book, Elevating Construction Takt Planning. I hope you are jazzed like I am that you get to go through this information. I listen to these as well. Isn't that kind of nerdy that I listen to my own podcast episodes? Super silly, but I love the content. Takt planning is absolutely fantastic. It needs to become our main system for scheduling and to hold all other systems accountable. I absolutely believe this. It will change your career. I'm glad that we're able to publish these things. I'm looking forward to talking to you on Friday. Just hope you're having a great day. So, welcome, without further ado, to the third section, which is titled The Concept. Let's do this.
The concept. What is takt? Takt planning is a detailed, one-page, one-piece flow schedule that focuses on throughput, bottlenecks, and ultimately creating flow. It is accompanied by lean practices to be the most efficient scheduling tool in the industry for construction because it is inherently most effective at reducing waste. Takt is taken from a German word that means cycle time. It symbolizes the need for a responsible rhythm of work in certain production areas, otherwise known as takt zones, as opposed to the left justifying of activities to their early start dates in CPM's famous forward and backward paths. To a builder, takt communicates the need for flow. Here are commonly found definitions and usages for flow. 1. As a verb. A. Of a fluid, gas, or electricity, move along or out steadily and continuously in a current or stream. Example, from here the river flows north. B. Go from one place to another in a steady stream, typically in large numbers. Example, the firm is hoping the orders will keep flowing in. 2. As a noun. A. The action or fact of moving along in a steady, continuous stream. Example, the flow of water into the pond. B. A steady, continuous stream of something. Example, she eased the car into the flow of traffic. When water flows, it runs in a relatively consistent and continuous stream down an unobstructed path. When water does not flow, it's usually due to twists, turns, obstacles, changes in elevation, or other hindrances. Additionally, water flows when it runs together in a coordinated pattern with adequate space. To explain what we mean, consider 2-gallon jugs of water. The first jug is tipped over and pointed straight down, allowing the water to pour out without squeezing the jug. As the water pours out, there is a gurgling sound caused by the friction of the air and water fighting for space as the jug empties in a time span of 11 seconds. In contrast, the second jug is turned over and the bottle is spun in a circle, which creates a spiral in the water, or flow vortex. As the water spins, the center of the vortex allows for the air to flow into the bottle at the same time as the water is flowing out. It only takes 5 seconds to empty the second jug with the use of the flow vortex. The best flow of water is developed by coordinating the water in the most optimized manner and by creating space in the center of the vortex for the air to rise. Forcing the water through the opening as fast as possible is not effective and causes splattering and turbulence. This is what happens in CPM by pushing construction activities through the network of resources as fast and/or as soon as possible, like in early start. The critical path will erupt with roadblocks, like air bubbles, that interrupt the flow and increase the overall duration of the project. Takt, on the other hand, with its coordinated approach and the space given for the occurrence of the roadblocks, meaning air, it's similar to the flow vortex. When all parts are working together to achieve flow, the water can move in a steady stream while simultaneously allowing air to rise up through the center of the flow vortex. This will beat the other system every time because it gives space and time for roadblocks to rise and to be removed from the flow of work. We've discussed this at length because we want this visual to stay with you throughout this book and as you begin your journey to bring flow to your job site. The ultimate question for any successful scheduling system is, at least in part, does the system enable a visible and coordinated flow? And does the system bring problems to the surface quickly so that they do not interrupt the flow? The answer to these will guide us as we take this journey. Flow is a priority in construction. But why? Because flow enables the very long supply chains upon which we rely in construction by holding to consistent dates, and it reduces the inventory levels on a project site at the end of that supply chain by allowing us to bring out materials just in time. This is important because the reduction of material inventory is essentially the reduction of overproduction in construction, which then reduces all other wastes. When overproduction and excess inventory are reduced, the need for fixing defects, overprocessing, waiting, transportation, and motion are reduced because we are using the genius and capabilities of the team by maintaining a consistent schedule and flow. The effects that waste, variation, and roadblocks have on production in the field are widely recognized and accepted, and at a minimum, they culminate in wait times and prevent good flow. If we maintain flow, prepare our work, stabilize our supply chains, and hold our dates according to a good takt time, we will have a good flow of information, manpower, and materials because the dates, rhythm, targets, and expectations all remained consistent, steady, and continuous, just like when water flows. Scrum and Last Planner systems also advocate and support flow, but are not able to maintain it fully when based on a CPM system because they are not receiving materials on time. Takt is the best companion to these systems as it can properly identify key milestones within a flowable system. Takt levels the workload to the point that agile systems like Scrum and Last Planner have a fighting chance. You can take the best basketball players in the world and encourage them to make slam dunks after you've placed the hoops 25 feet in the air, but they will fail in their endeavors. That does not reduce the effectiveness of the players. It means the game itself was impossible. When CPM puts Scrum and Last Planner into a game with unrealistic end dates, non-contextual and rhythmic milestones, and non-transparent plan visualization, we are setting our hoops 25 feet in the air. Takt brings us a game we can win, with rules we can follow, and the autonomy to meet short-interval scheduling targets. It brings the hoops back down to 10 feet so the players can again dominate on the court. Definitions. Before we continue, it feels appropriate to define some terminology as we move forward in our takt journey. Takt, German for baton, beat, or rhythm. Takt plan, the visual plan that shows the takt trains in relationship to each other per the specified takt time with columns of time and rows of takt zones, or geographical locations, or general scopes. Takt phase, the grouping of takt trains and zones that compile to make up similar types of scopes, for example, structural, rough-in, exteriors. Takt zone, a standard production area that is determined by its repeatability and ability to fit into a rhythm with other areas to balance the overall takt time rate. Takt train, a series of wagons in a takt zone. Takt wagons, one or more work packages or scopes of work in a takt train, usually shown in a cell on Excel. When two work packages can be done in the same takt wagon block, they are done at the same time and considered as one. Work packages, features of work or scopes within a takt wagon. If found within the same takt wagon, they should not constrain or hinder each other in any way. Work steps, the tasks in the installation process within the work package. For example, if your work package was OH electrical, then the steps might be conduit runs, light boxes, fire alarm, cable tray, low voltage, etc. Takt time. Measurable beat time, rate time, or heartbeat. In Lean, takt time is the rate of which a finished product needs to be completed in order to meet customer demand. It is the syncopation or rate of beats, such as one might find on a metronome. Takt time is the duration of the time scale into which the takt wagons are fit. If the takt time is 5 days, the wagons fit into multiples of that duration. So if a wagon includes the work package of overhead mechanical, and that overall duration is 15 days, and the takt time is 5 days, there will be 3 takt wagons that say overhead mechanical in 3 time scales. Stagger. The difference in the start dates or end dates for takt trains that educated the throughput calculation with time. Flow. When something moves together along a steady, continuous stream with a lack of resistance or turbulence. Waste. Any non-value added unnecessary work steps or conditions that hinder normal operations from delivering value to the customers on the project. They usually are classified within the following categories: overproduction, excess inventory, transportation, motion, defects, overprocessing, waiting, and underutilizing the talent of the team. Variation. A change or difference in the condition, amount, or level of anything in construction that interrupts the flow of work as planned. Resource efficiency. According to Lean, resource efficiency focuses on efficiently using the resources that add value within an organization. Flow efficiency. According to Lean, flow efficiency focused on the unit that is processed in the organization. Throughput. The rate at which material or items pass through a system or process. When you take raw materials and process them into finished goods and deliver it to the customer, the measured rate of that activity is your throughput. Overall duration. The start date and end date of the construction of the project, which can be determined by takt planning or stipulated beforehand, to which the takt time needs to be adjusted to meet. Roadblocks. Anything that has the potential to impact work in construction that can be identified ahead of time and can be removed before the work begins. These are temporary roadblocks, and the removal of them should be the main focus of the team. Examples of roadblocks are missing information, a defective part or material, coordination issues, procurement issues, and errors in pre-planning. Constraints. A condition on or around the project that limits or restricts someone or something in the course of the project. These are typically permanent and cannot be removed. Examples of this might be adjacent geographical features, weather, lack of space, municipal restrictions, or anything else that permanently defines the parameters of the project. A project must be successfully planned and carried out within these constraints. We use the term constraints much differently than the Lean community at large. It would be our preference that we adjust back to the proper use of the word constraint as something that must be dealt with and begin to use roadblock to define removable blocks to flow or production. Bottlenecks. A bottleneck is any resource whose capacity is equal to or less than the demand placed upon it by the entire system. Inventory buffers. The stock of either raw material or final product a company maintains as a protection against unforeseen circumstances that is neither excessive nor too small to stop work due to a lack of materials. An inventory buffer is considered right sizing to enable work, but does not create unneeded inventory that needs to be moved, replaced, repaired, or processed. Just-in-time deliveries. A strategy in supply chain management intended to synchronize orders from suppliers by production areas and standard delivery schedules to the project site in the right amounts at the right time to supply inventory buffers. Takt history. Takt time is taken from the German word Taktzeit, meaning cycle time. According to Colin Disharm and Todd Rudick, who teach Lean Six Sigma courses, the word was likely introduced to Japan by German engineers in the 1930s, which explains why lean and takt have an interwoven history. The actual word originates from the Latin word tactus, meaning touch, sense of touch, or feeling. Some earlier meanings include beat triggered by regular contact, clock beat from the 16th century, beat indicating the rhythm pertaining to music, and also regular unit of note value from the 18th century. Takt is focused on the rhythm of sequences or geographical areas on the project site, sometimes known as location-based scheduling. European countries have successfully been using this type of scheduling for years. Takt planning has been called a variety of names over the years: one-piece flow scheduling, linear scheduling, SIPS, line of balance, or even flow production. It feels appropriate to call it by the name of Takt because it has a good brand name throughout the industry and allows us to rally behind the concept together. Takt planning can be seen in the construction of the Empire State Building and more recently in the United States Pentagon renovation constructed by Hensel Phelps in 2002. Despite both of these projects being wildly successful, CPM continues to be the dominant scheduling system in the United States. The argument for CPM is typically the favoring of data and data mining. However, visual schedules and uniting the workforce around a common plan should be more important. Unfortunately, as long as we have paper managers wanting only to look at the numbers instead of leading people, it will continue as a standard. Here is a preview of Jason's journey with Takt. 2006. Hearing about the Pentagon renovation, Takt planning was used in the Pentagon renovation by Hensel Phelps and called a SIPS train. I first saw this in a scheduling presentation and was intrigued. 2007. Seeing the templates. I was able to see a template and learned about the SIPS rules that governed the system in the Pentagon. 2008. Scheduling Summit. As a young assistant superintendent, I attended a scheduling summit and learned about CPM and was exposed to a brief lecture on SIPS. 2011. The Cancer Center. As a superintendent over the interiors of an $80 million cancer center, I implemented Takt planning and called it a block schedule. Results were amazing. I developed my own rules and uses for the system. 2015. The Research Laboratory. The Research Laboratory. As a project superintendent, I again used Takt for the interiors, including prefabrication, flow, geographical control, just-in-time deliveries, and other lean support systems. I called it a one-piece flow schedule and recorded the process on video and posted it to YouTube. 2017. The Pharmacy. I began using Takt planning for the entire project and expanded the system. 2017. The Office Building. I used Takt to perform a flow analysis for a complex exterior system for the first time with success. 2018. Implementing company-wide. I began using Takt planning for all projects throughout the company and throughout the construction process, including pre-construction. There were over 80 active projects, not including the countless others in pre-con. 2019. The basis for all scheduling systems. I standardized this system with the scheduling department and across all projects as the main approach to project scheduling. 2020. Scaling Takt. I developed the Integrated Control System and integrated it with Takt. I also developed operations standards that could be scaled across the country to easily enable operational success. 2020. Elevate Construction IST. I began a coaching, consulting, and training business intended to elevate the industry. We began writing Elevating Construction Takt Planning, developed an online Kajabi series for Takt planning, and began consulting on Takt, online, and/or on location. Takt, as outlined in this book, is a modification of the system used at the Pentagon renovation, updated with the current German methodologies. Takt philosophy. The river of waste versus flow trains. The river of waste is a good analogy and it is useful, but our industry doesn't correctly understand it yet. The river of waste has been described as a lean analogy, where the boat on the river is the flow unit, the rocks under the water are the roadblocks, and the water represents resources. The goal of the boats is to travel down the river. In our wasteful industry, especially in the United States, project teams raise the water level, which is equivalent to increasing manpower, money, crews, and other resources to allow work to progress. The recommendation in the lean analogy is to actually lower the water level, expose the roadblocks, remove them, and move the boat down the river. The problem with that, at least in construction, is that teams lower the water level, meaning they reduce resources by the slash and burn approach of reducing budgets, shortening deadlines, and undercutting team sizes. All this amounts to is a more shallow river still going too fast, with no time to see and remove roadblocks. The team has to increase the water levels anyway. The only difference with this is that the project was underbid, so now it comes out of contingency or fee. The industry's understanding of the river of waste is currently flawed and causing problems. Lowering the water level is not the solution. Rather, it's having the water level at the right height, going the right speed, and stabilizing the flow. We do not need to reduce the resources. We need to stabilize them. Going back to the analogy, if the water level is right, going evenly and with a smooth surface, the team not only can see the roadblocks in the water, they will have time to remove them before their arrival. To summarize, we are not trying to needlessly reduce resources. Rather, we need resources planned at the right speed and quantities so that roadblocks can be removed in a timely fashion. Additionally, if this is the approach, the project team will bid the right amount of time and resources and actually have a chance to make a decent fee. It is the only way, and Takt does this. Because comparing the flow of construction to water and a river is problematic, we'll use a train and railways to demonstrate the practice of reducing waste. Consider the following. Land surveying. When a railway is built, the path is determined by surveying the terrain and finding the path of least resistance. Therefore, determining takt time and the throughput is like land surveying the railway before construction. Design. The overall design of the takt train is like the printed takt plan. Clearing the path. It is important to fill in the valleys and excavate the hills before laying the track. Leveling the flow of work with trades by locking them into the takt time and plan is akin to clearing the path. Railroad ties. Railroad ties are the foundation of the train's flow. The ties are what creates stability. This is analogous to the integrated control system. Creating lean contracts. Creating lean contracts, winning over the workforce, implementing accountability systems, building the team, creating team coverage, implementing the team meeting cycle, and creating a safe, clean, and organized project is the foundation for a stable takt system. Rails. The rails on the tracks are what allow the train to move quickly. This is prefabrication. If you have the foundation, the system, the flow, and the team, having prefabrication assemblies from coordination to the largest extent possible is what makes takt, or the train in this analogy, go fast. Cowcatcher. Just like the cowcatcher removes debris from the track to clear the path, the cowcatcher on the project site is a fanatical roadblock removal system using roadblock maps. Front engine. The front engine is the pre-planning team that prepares the way and brings the work into the area on the right start date. Freight cars or takt wagons. The wagons are the resources that carry the product forward. Work packages. Work packages are the scopes of work that the resources carry out. Takt wagon covers. Wagon covers keep any product from being left behind and symbolize the effort to finish as we go in a takt system. Speed of the train. The speed of the train is the takt time. Arrival sequence of trains to the station. The throughput of the system. Mountains. Mountains represent constraints. Roadblocks can be removed, and constraints are the things the project needs to be built around. The example is pretty straightforward. A railroad is intentionally made. A river is based on circumstances in the moment. If you think about it, most lean scheduling systems encourage reactionary planning in the moment, which is a lot like floating on a river you can't control. Conversely, creating a railroad, creating a system of control, is akin to Takt, where we make our own destiny and control the work. So don't build boats when you can build trains and railways. It should be noted that Takt has nothing to do with any dictation or old-time command and control systems. Takt is a collaborative system where we predict as much of our future as possible and prepare for success instead of hoping for the best in the moment. On construction projects today, we need stability rather than the reduction of resources. And stability relies heavily on rhythm. There is a famous saying from the U.S. Navy SEALs, "Slow is smooth and smooth is fast." We would like to repurpose it as rhythm is smooth and smooth is fast. The point is that rushing takes longer than going at the right rate. The decision is not between going fast and finishing early versus going at the right rhythm and finishing later. The decision is between going fast and failing versus going at the right rhythm and having a fighting chance to win. The decision is between going fast and finishing late versus going at the right rhythm and finishing on the earliest possible date. So rhythm is key. It is the pace at which flow units or work is completed within the project, and that rhythm is determined by capacity. The rate at which we can complete buildings is not determined by randomly turning the dials of manpower, money, and other resources, like the incorrect interpretation of the river of waste analogy. The rate at which we can complete buildings is determined by the capacity of the local market and how much manpower is available. It is determined by how many materials can be produced and how much money an owner will pay for the project. Each of these resources have a capacity. It is critical to understand that capacity and adjust the takt time and throughput to incorporate it into the overall plan. There is little merit to just making a plan to fit the stipulated end date when there is no capacity to do it. Takt works when we follow a rhythm. Takt planning really only works when we get the rhythm right and when we focus on that rhythm. As we've said before in this book, CPM slams everything to the left towards its early start. As builders, when we build, implement, and manage with Takt, the focus is on the rhythm. The rhythm, the stagger or throughput, all nearly interchangeable terms, allows the design to be done just in time, material approvals and permits to be leveled, and the load of the team to be even throughout construction. Following a rhythm also reduces the likelihood of overburdening trade partners and crew resources. Flow is king, and the right rhythm enables that flow. Imagine freight cars behind an engine crashing into each other or stacked on top of each other. This is not the ideal state. The ideal state is when cars, or takt wagons, are evenly spaced one behind another in a row. That is takt. That is flow. That is rhythm, the even flow of work. When we overburden resources or work steps, we lose our rhythm and overload the system. That is why we focus on rhythm, and we see that rhythm because it is shown on one page. Takt plans, when printed, are used in a remarkable fashion when they are shown on one page. A member of the management committee at DPR Construction once intimated a plan should be easily seen within 5 to 30 seconds of walking into the office trailer or coming onto the project site. Try doing that with a CPM schedule or even a graphical schedule based on a CPM schedule. If you try to do that with Takt, you will hit the mark most of the time. It is best practice to show the project Takt plan on a single sheet, whether that be 11 by 17, 18 by 24, or 36 by 48, so that the plan can be quickly seen, understood, and acted upon by everyone on site. The best implementation of Takt planning is when every foreman has a laminated copy with other postings of the plan showing up at the hoist, on-floor lean boards, in the conference rooms, and in scheduling deliverables. If it can be shown and understood on one page, we can see as a group, know as a group, and act as a group. And when we see that stability, we bring materials just in time. With Takt, project teams, and especially superintendents, need to hold the dates and avoid the temptation to jockey the starting dates of scopes forward and back randomly outside the collaborative plan of the project team with trade partners. Why is this so important? Because variation creates excess inventory levels and disrupts the flow of all resources on site. When trades know the super will not follow the plan and will likely move up their start dates, by habit the trade supers and foremen will begin to increase inventory levels to anticipate their whims. And every time inventory levels rise, so do manpower counts and the costs to manage them. Only when a schedule is predictable can just-in-time really work. And it only works when we hold the dates. So just-in-time deliveries really only work with Takt planning and really only work when project teams hold to the rules of Takt by holding the dates. Now, there are some exceptions to this rule. If there is a major shift needed for project success that can be coordinated with all participating contractors on site and that can be coordinated with procurement, then this type of change may be acceptable. Additionally, when a project is coming out of the ground, expediting or advancing the schedule is more appropriate because there are fewer contractors. Therefore, it is more acceptable in the early phases, but only under rare circumstances should dates be moved and start dates be adjusted when there are over 10 contractors on site working in rough-in, exteriors, or finishes. With Takt systems, we need to hold the line, keep the rhythm, and be disciplined. Otherwise, the system fails. Therefore, Takt planning requires project teams to hold others accountable, control the site, and hold the line. This is very difficult for a team and can be a reason project teams may be hesitant to use the Takt system. It is also why trades may be hesitant to participate with Takt because they will be held accountable. You can be sure that weak leaders and non-accountable trades will not like Takt. This keeps the system stable, and then the team can accelerate when we prefabricate as much as we can. Consistent and stable scheduling systems plan the work in the field, and they need to be supported by prefabrication. When a project is entirely stick-built, it will generally experience uncoordinated work with slow and unpredictable installation rates, which will not allow flow. To be as effective with Takt planning as we can be, we need to prefabricate as much as possible within the project budget. Prime examples of this are overhead MEP, head walls, corridor racks, exterior wall panels, and standard plumbing racks. It would be ideal to continue with that goal and add in concepts like underground MEP, room kitting, where we pre-cut and kit entire rooms, structural prefabrication, form prefabrication, pre-cut studs, header prefab, exterior cladding prefabrication, and finish assemblies. The vision for this is limitless, and the point is to move workers into more stable environments, such as the shop, where the production of assemblies is safer, more controlled, predictable, and there are better conditions for workers. Basically, following an assembly schedule is easier when you can piece it together like Legos or IKEA furniture. We must prefabricate as much as we can to create consistency and flow. The prefabrication of drafting, detailing, and assembling the scopes before they arrive on site will allow teams to discover issues earlier, which reduces waste. This will enable teams the time to focus on the pursuit of identifying and removing roadblocks everywhere in the system. By following traditional CPM, a superintendent's time was mainly spent managing the schedule and the chaos caused by not hosting remarkable meetings and communicating a stable plan. With Takt, we have remarkable meetings according to the standard meeting schedule and builders who can focus on being builders in the absence of having to manage a complex schedule. Significant time is now spent on preventing interruptions, waste, and variation. Before, the time spent managing the schedule was at 60% of the day, and now it is at 5%, so the remaining 55% gain is focused on preparing the work, identifying roadblocks, and then removing roadblocks. The system can only be successful if the project team is committed to doing this, because there is little point in creating a stable scheduling environment if it is doomed to encounter a chaotic installation process where ignored roadblocks bring the system to a halt. In Takt, with knowledgeable builders, most or all roadblocks will be successfully cleared from the path in time using this system. This happens when we control geographical areas. The control of geographical areas, or Takt zones, is one of the main benefits of using a Takt system. Since most areas are broken out into 10,000 square foot areas, the standard flow of work through a building, according to the Takt plan, lends itself to a great system of trade partners controlling their assigned areas for safety, cleanliness, organization, ownership of trade damage, roadblock removal, and a host of other things. In chaotic scheduling systems like CPM, the lack of consistency moves the responsibility of areas back to the general contractor because there is no clear identification of where and when trade partners will be working. This all changes with Takt. And while it can be an abrupt culture shock for some contractors, it works very well. Where we have geographical or Takt zone control, we have control of the project because supply lines, organization, and the safety of workers help productivity as much as quick hands at work. As trades help control areas, they also focus on throughput, not individual efficiency. The throughput through the entire system is our focus, not individual efficiencies for trades. Stated differently, flow efficiency should be our focus, not resource efficiency. Flow efficiency is the efficiency of the flow unit or the work, and the resource efficiency is the focus of resources being used at maximum capacity. As listed in the definitions section, the throughput is defined as the rate at which a certain amount of material or items pass through a system or process. The more efficient that this material is as it passes through the system, and in this case the building, the better our throughput. Individual efficiency is concerned with the production or utilization of individual resources or contractors, which does not always help the overall throughput. We need all contractors working at relatively the same throughput and takt time in order for there to be flow. If contractors are working faster or slower than average, it might seem helpful to that individual trade partner's productivity, but it interrupts the overall throughput, creates variation, and increases inventory levels, which increases defects, which increases, well, by now you get the idea. So in some instances, we have to speed up certain resources and slow down others. This is called leveling out around bottlenecks. Some may be very concerned about our comment to slow down certain resources, but consider what happens when, after we have optimized and sped up all bottlenecks, we continue to let the faster trades continue to go fast. What happens? People are stacked in certain areas without flow, without geographical control, burying certain scopes, and or installing too early, which increases the amount of defects and use of resources, such as the project management team's time. This affects the trades that really need the help. There is little merit to going faster than the general takt time within the area of the takt zone or work package. The best practice is to first optimize the bottlenecks or the slower installations, and then to even out the flow, the rhythm, the throughput, and the takt time of the remaining work, and therefore the entire system. This allows us to finish as we go. For takt to work well, we have to finish as we go. Historically, superintendents have attempted to accelerate the project to gain time at the end to fix all the mistakes from going too fast and not installing it right the first time. With Takt, we cannot have, and we should not need to have, that buffer of time for an excessive punch list. With Takt, and while working to prevent roadblocks, the team, and especially the engineers, will be inspecting work, identifying punch list items, and working with trades to correct as they go, meaning they finish as they go. Before a trade leaves the area or the project, They should not only install the production work, but they should finish the scope in its entirety. This will take a mindset shift for most of the leaders in construction. But when this path is taken, we will see a better quality product delivered to the customer sooner. We can do this when we see as a group, know as a group, and act as a group. Takt, again, is a great communication tool for the project team to see what needs to be done and when. If we can all see that, we can make decisions and collaborate with a common knowledge and therefore act or head in the same direction together. As Patrick Lencioni quoted in his book, The 5 Dysfunctions of a Team, if you could get all the people in an organization rowing in the same direction, you could dominate any industry in any market against any competition at any time. This is what Takt Planning does for us. Takt, along with Scrum and Last Planner, help us to move in the same direction by allowing us to see as a group, know as a group, and act as a group. Seeing the plan is powerful when Takt shows reality. When Takt Planning works best, the Takt plan always reflects reality within about 2 to 3 days of accuracy. Instead of falsifying logic and adjusting sequences like CPM does, Takt works like a series of freight cars or wagons that cannot be stacked on top of each other. When one car moves, the rest move. When updating progress on a Takt plan, impacts are not only seen that same day or week, it also shows what it does to the rest of the Takt train, the remaining Takt trains, and their corresponding throughput. This forces the hard conversations early. Additionally, when teams target to complete Takt wagons and work packages on time, the fear or avoidance of commitment brings roadblocks to the surface. These problems, meaning the actual visualization of delay impacts and the exposing of roadblocks, are not inherent with Takt. They are simply visual with Takt, and you can see reality. With CPM, problems were hidden in the chaos. Takt works, and will always work, when the system is followed and reality is shown in clarity. That is why Takt is lean. Our definition of lean is respect for people and resources, stable environments, and continuous improvement. According to that definition, Takt is lean. There is no scheduling system in construction that has more respect for people and resources, nor one in which more stability is created. Additionally, without stability, continuous improvement is not possible. So again, Takt is lean. Takt is flow, and flow is lean. As for continuous improvement, no team will take the time to continuously improve unless they have the stability and the time. Takt provides this, and ultimately, that is why Takt is the way to cultivate respect for workers. Takt is so powerful as a communicator of a plan that every laborer on site can see the plan and understand how he or she is relevant to the project. This tool is the best way to not only achieve flow, but to communicate it outwardly and make the complex be understood in a simple way. When we plan a project with the wrong end date, for the wrong budget, and with materials that cannot arrive on time to maintain a flow, we disrespect workers and their families. Ultimately, they end up paying for the mistake by being overworked, rushed, put into unsafe situations, and being pushed. Not only is respect for workers and resources needed for stability, it is just the right thing to do. No company should be able to succeed while disrespecting people, especially the people installing the work. To fully grasp this point, we need to understand muda, muri, and mura. Muda is a Japanese word for waste. Muri means overburden, and mura means unevenness. In the United States, we usually only focus on waste and not overburden and unevenness. Overburden happens when a system is made to perform at more than 100% capacity, and unevenness happens when variation enters the system. We know that the 8 wastes can create overburden and unevenness, but when we do not have the right rhythm and throughput, it causes overburden and unevenness as well, which in turn will create 8 wastes. The 8 wastes in construction are overproduction, inventory, defects, overprocessing, wasted motion, transportation, waiting, and not using the genius of the team. So here's the kicker, the plot twist, the key moment and the climax. Are you ready? Are you sitting down? Get ready. A lack of stability creates these wastes. When there is no stability in construction, when the system is overburdened, and when the system is uneven, trades will overproduce and bring out too much inventory, which creates the other 6 wastes in construction. Each waste inevitably causes more waste, and the additional cycle continues until someone with a subtracting cycle comes along and breaks it apart. So, if you want to eliminate waste, you will reduce variation. Variation is undoubtedly the enemy. It is the antagonist in this story, period. The reason why the leveling of takt wagons is lean is because it is breaking work into similar duration features of work and creating a task that needs repeating in other areas as well. Variation, when rampant on the project site, creates all other wastes, interrupts the systems, and increases the amount of resources needed to complete a project. The problem is that variation affects throughput. Throughput is best illustrated by the late Eli Goldratt, father of the theory of constraints. In his book, The Goal, when you take raw materials and process them into a finished good and deliver it to the customer, the measured rate of that activity is your throughput. End quote. Throughput, then, is the rate at which a finished product is completed as it flows through the entire system. Meaning, the word throughput concerns itself with flow and not with efficiency. So in a system, all production, all resources, and all efforts, when produced at the same throughput, create the steady flow. If not, the system slows down. That is why we must have one-piece flow. One-piece flow is a concept centered around flow units progressing from inception to the customer on the shortest path possible. All parts are working in unison, accepting and passing work to the next trade in line in the sequence. It means that we reduce the amount of work in process, and we finish one piece of work as we go, and move work down the line in smaller amounts as opposed to batching. Don't do this. Batching occurs when product, work, or assemblies are created in groups to increase the efficiency of resources rather than flow. Batching work in construction looks like doing one scope of work throughout the entire floor or entire building without respect to flow. A good example to show the difference between one-piece flow and batching is the envelope game. In the envelope game, 2 contestants are given 20 envelopes, papers, and stamps. The first contestant is told to fold all the papers at once, stuff the papers at once, lick them and seal them all at once, and then stamp them at once. The second contestant is told to fold, stuff, lick, seal, and stamp each of them one at a time. Each contestant starts at the same time and is asked to finish as fast as possible. It is nerve-wracking to watch this game because the batching contestant looks sure to win. But with 2 minutes to spare, the one-piece flow contestant finishes first. One-piece flow is faster and always will be because it releases work on a rhythm and allows work to flow. The batching system is usually preferred because it looks like it goes faster, but that is simply because it is riddled with motion and transportation, picking up envelopes, putting them down over and over, which is waste. With takt systems or flow systems, we finish as we go or follow the concept of one-piece flow, which means the work is delivered to the customer in the fastest way possible. Good, better, and best. What does the industry do now? Good. A brief look into current industry practices is important as a preface to what we are suggesting with the use of takt systems. The master schedule. A master schedule is built, usually in the proposal phase, and detailed to a point that it can be used for short intervals and sometimes day-to-day production. The schedules are built by superintendents or professional schedulers and are updated either weekly or monthly to track progress and identify red flags. The schedule is usually built with a work breakdown structure, completely logic-tied, and lastly, with a finish on or before constraint to force the calculation of total float throughout the system. The schedule is designed for production tracking and milestones. Milestones are arguably the main focus of CPM scheduling, in addition to the identification of critical activities within a given month. Project teams use milestones to rally the team and track progress. These are calculated from the overall network according to the typical construction milestone points, where a transition between phases is more easily identified. These are targets that can be compared against look-aheads. Look-ahead schedules are used by the project team to orient subcontractors and plan materials, manpower, information, and equipment. Subcontractors are typically given this plan as a directive from the general contractor without much collaboration, and subs are expected, by culture and by contract, to obey the schedule and meet their dates. Work is carried out without asking, what do workers see? The workers do not see any of this planning. They are told what to do by their foreman, who at best attempt to follow the uncollaborative and dictated schedule, and at worst follow their own plan and ignore the request of the general contractor and their schedule. This results in an environment that is like firefighting in the office. The famous American sitcom The Office aired an episode entitled Stress Relief, in which Dwight attempts to test fire safety and response skills by locking doors, disengaging phone lines, and starting a small fire in the wastebasket. Pam sees the smoke and screams, "Oh my God," and everyone panics. The characters break windows, climb into the ceiling, throw a cat, and break into the vending machine. Stanley, who has a heart condition, collapses on the floor following Dwight's belated announcement that the entire thing was a drill. There are similarities between this episode and working on a project governed by CPM in the old way. People run around in different directions with a false sense of urgency just to find that the communicated deadlines were either unnecessary or chronically too late anyway. The chaos, lack of direction, and siloed thinking is accompanied by waste and variation, which cause the project to fall behind. Before long, project teams start throwing manpower, money, and materials at the project in hopes to finish on time, which is the metaphorical equivalent of putting out a fire with $100 bills. It's crazy, and yet it's actually pretty standard in construction. So, what are we being told now? Better. Thankfully, the problems the construction industry has been facing have not gone unnoticed, and many are committed to providing solutions to remedy the situation. Systems like Last Planner and Scrum are being adopted without mincing words about the failures of CPM, and they are making a difference. But to fully turn the tide in this situation, we need to correct the overall master scheduling process by planning with more consistent dates and by better managing supply chains. Let's take a look at what we're being told now. Let's start with the master schedule. The master scheduling we've described remains largely the same, with the adjustment that these schedules should be created at a higher level of detail so Last Planner and Scrum techniques can take over at the right level of detail. The master schedule is still used by the first planners throughout pre-construction and during construction as a long-term planning tool, mainly to identify and track progress towards milestones. Milestones take on a different role in the new system, where they used to be compared to actual progress and 3 or 6 week look-aheads. Now they form the constrained end date for phase planning efforts with pull planning techniques. The focus of the system is to make clear that milestones have to be hit, but that getting there is a collaborative effort that should be used in a process called phase planning. Phase planning is a process where the project team, under the direction of the project superintendent and/or project manager, anticipate key milestones that represent a phase of work. This planning is usually facilitated with a process called pull planning. Pull planning is a lean process where trade partners, with the project management team, identify the proper sequence of work according to the project needs and the needs of each individual contractor. Per tradition, the practitioners usually identify a milestone on the pull planning backdrop, and each contractor, after proper preparation and onboarding activities, places tags or stickies on the wall in a format that identifies the point in the sequence, the duration, company name, crew size, and needed predecessors that will allow the activity to take place. The teams create the sequence together through practices and rules that should provide a final sequence that is more realistic than a dictated plan from the general contractor that may have been made in a silo. This coordinated sequence is then included in the overall master schedule or simply placed on planning boards or a project application that houses the data. This new sequence allows the team to filter out make-ready look-aheads. Make-ready schedules are those which have been coordinated with on-site constraints, other activities, and the capacity of resources on the project site. It is usually the first schedule that the team uses to foresee roadblocks. Its main purpose is to allow all members of the team to plan accurate dates to which trades plan the delivery of manpower, equipment, materials, and information. These schedules direct the team's focus to preparation by removing roadblocks, sometimes incorrectly called constraints, and by planning resources so that more firm commitments can be made when the project team creates the weekly work plan. The weekly work plan is the plan for the next week, where detail is pulled from the make-ready schedules, in addition to any new detail. Contractors detail out their activities ahead of time and arrive at the meeting prepared to coordinate their work for the next week, so that everyone has the space, materials, time, and information needed to complete the work. Trades leave with commitments to each other and a single plan that is visually easy to understand, well communicated, and coordinated daily in huddles. The project team huddles every day to discuss plans for the day, safety, and to coordinate logistics as the crews mobilize into key areas. The daily huddle is where on-location and daily planning is done to carry out the weekly work plan. The team's success in doing this is tracked with what is called percent planned complete. Percent planned complete, PPC, is a percentage of tasks completed properly and on time as committed in the weekly work plan. The percentage is tracked daily, weekly, and monthly to show the team their progress in making real commitments and producing as a collaborative team. Teams that score under 80% historically have budget and overall schedule problems, and teams that score above 80% statistically do well with a budget and overall schedule. When a date is missed, the team tracks it as a variance, and when variances repeat, the team reflects on how to prevent them in the future. Even though this is well-intentioned, the question still not being asked is, what do workers see? In this system, although the weekly work plan and daily huddle attempt 100% commitment between trades, the workers only see about 40 to 50% of the plan because the system relies heavily on the transfer of information between the foreman and the workers. Additionally, most of the time, the crews still hit the ground running without much pre-planning, and leaders are in huddles at the start of the day when the work starts. This usually results in workers losing valuable time when the foremen come out of the meeting and change the plan based on the daily discussions. Although the system is better, it does not get as much information as possible to the worker. And primarily, the system is based on milestones that are unrealistically planned in CPM, which again sets up a situation that is unattainable from the start. We happen to love Last Planner, so we modify it to cater to an ultimate flow. So let's ask, what should we do best for now? The process that we advocate in this book has been lovingly titled the Integrated Control System. It is intended to communicate the need for project teams to collaborate, plan, lead as a team, and control an operationally stable environment in the field. With CPM in the old fashion, this was not possible because schedules were created in a silo. CPM with Last Planner or Scrum does not entirely work because the first planner system, CPM, is still done in a silo, even if that changes once Last Planner and Scrum take over. Only when we use a collaborative tool like Takt with Last Planner and Scrum can the entire system, from the beginning to end, be fully a team effort. This is the target. This is the goal. Remember back to the analogy of the vortex. Pouring water out alone didn't provide the fastest movement of water. Only when the water was moving together in a common direction causing roadblocks or air to rise to the surface did the water move as quickly as possible with little variation. That is why we should begin with takt planning. A takt plan is quickly created, easy to see, condensed enough for multiple people to interact with it, and effective as a communication tool. It is the best tool for identifying the proper overall project duration and can communicate problems with flow when the schedule attempts to fit within a stipulated end date or duration. The takt plan is also very effective with showing how the building should be broken up into a work breakdown structure. Once the takt plan is created, including all project phases per the proper takt time and showing the right throughput to meet the end date, then the plan properly shows milestones. Milestones are better identified with a takt plan rather than the systems like CPM. Once the team can see the overall project plan, the flow, the key transitions, and interfaces within the schedule, key milestones can be identified easily and effectively because they can be easily seen. This is important because project teams will want to begin planning as the current date approaches these milestones. This is called phase planning. Phase planning is done roughly the same way it is currently advocated in the industry, with a few minor modifications. We still plan up to appropriate milestones. We still do it together as a team, and we get commitments by consent, but these are done either by adding detail to the takt plan in the main higher level format or on the day-to-day takt format as a more detailed layout in the takt plan. Additionally, it can be transferred to the planning boards in the project collaboration room or transferred to the online Last Planner application. Once the team creates the coordinated plan and sequence for the phase up to that milestone, the team now has a plan that can be filtered into make-ready look-ahead schedules. Make-ready schedules may be viewed as a focused timescale on your planning boards or filtered to the right duration in your Last Planner application on site. They can then enable the team to plan materials, manpower, information, and equipment to more accurate dates early enough to avoid variation. These look-aheads can be 3 weeks, 6 weeks, or 4 months, depending on what the project team needs. As resources are planned on this type of schedule, it enables a fanatical roadblock removal system. As teams look at each activity, it is best practice to ask the following questions. Are materials on track to arrive for this activity? Are they approved? Is safety planning done for this activity? Are all needed permissions available? Is the right equipment scheduled for it? Is all needed information available? Are crews with the right person counts scheduled? Are there any roadblocks preventing this activity from taking place? This is typically done with activity cards or a matrix with the activities to the left and the questions in the columns above. Asking these questions enables a roadblock removal system. The removal of roadblocks should be the main focus of an effective and collaborative team. The making ready of work will always be more effective than adapting in the moment on a project site. Roadblocks need to be tracked in a manner that everyone on the project site can see and remove them, and observe progress daily. Foremen, field engineers, project engineers, superintendents, project managers, and directors can easily spot and focus on potential problems. A visual board is suggested, as well as visual maps and floor plans with roadblocks shown where they will affect work. Even if roadblocks are bulleted, as long as they are visual, the system will work. Then the team, including the director, makes the removal of roadblocks their primary responsibility. If this is done, then work will be made ready for coordination with weekly work planning. Weekly work planning can happen with tags, tasks, or stickies on the board or planning tool. But with Takt, it can also happen directly within the Takt plan in a general way. For standard, repeatable, and typical work, it is helpful to simply prepare work based on the Takt wagons within the time scale. For more complex work, Takt plans utilize the detail of a day-to-day format within the weekly work plan and can be shown on Takt cards, tags, stickies, dry erase markers on the board, or on your planning application. The weekly work plan should be in a location and format for key production activities to be filtered for the next week and shown in a way that supports day planning. Day planning is much more than simply talking about the activities for the day. It is the discussion, coordination, issue resolution, and effective communication of the day's plan in a visual format. It should focus the group's mind on the end date, the next milestone, and the key items that need to be discussed in a way that encompasses on-site interaction, productivity, and the location of all necessary resources. The goal is to achieve the highest percentage of plan comprehension from all workers on site. It doesn't make very much sense to spend months and years planning a project to then stop short of ensuring that every worker understands that plan. We do that by implementing the following huddles, and we start with afternoon foreman huddles. The afternoon foreman huddle increases the ability of foremen to plan and arrange supportive elements with roughly 16 hours in between the meeting and when the next day begins. Work is planned for the next day in detail so all leaders can see together, know together, and act together. But to act together, we need the buy-in and understanding of the workers as well. Leaders must ensure communication is reinforced in the morning worker huddle. So far, this system sounds exactly like the Last Planner system, but here is where we improve on the current industry trends. The morning worker huddle encompasses the entire project site. For large projects, major divisions of workers by functional area huddle together every morning to form a social group with the project management team in an exchange of communication regarding expectations and needs. Workers should leave the huddle with clarity and with a greater understanding of how to succeed on site, how to be safe, and feeling connected to the overall plan. They are then better able to plan in their crew preparation huddle. The crew preparation huddle is not new, but it needs more support and standard implementation. In this huddle, the foremen spend 10 to 25 minutes with the workers discussing the pre-task plan, preparing work, 3S'ing, discussing the 8 wastes, and doing general training. Every worker should leave with a PTP for safety and quality and be able to work in the right environment with the materials, tools, space, information, equipment, and clear expectations to succeed in a stable environment. This truly answers in the right way the question, what do workers see? In this system, which surprisingly does not take longer than the other systems, the workers see as much of the plan as possible. Using Last Planner, the worker might receive 50% of the planned information, which is a huge improvement, but not as good as the 75% achievement using the Integrated Control System, where information is sent all the way to the workers. Transfers of information, which are not caused by this system, but natural to construction, are facilitated with clarity and opportunities to buy in. Also, there are fewer single points of failure. In the Last Planner system, the successful transfer of information from the first planners to the last planners to the workers hinges on the ability of the foreman to communicate that plan. In the integrated control system, the transfer of information to the workers takes multiple paths and does not rely on a single point. The bottom line is that the workers can see the plan and have input. How do we get there? Rules of Takt. When Takt planning is implemented, the following rules are very important in keeping the system working well. Deliveries are scheduled on time, arrive on time, or they are turned away. No going faster or slower than the Takt, unless the team decides together and it is done as part of the flow. Work within work packages. Work weekends if they're not done. Contractors control the Takt zones in which they are working. Everyone has a copy of the Takt plan in the field. Follow the Takt and pull contractors behind you at the right time. Remove roadblocks daily as the first priority. These rules are Takt specific and are also best supported when standard operational rules are enforced, as listed below. Everyone knows how to be safe in their task. Everyone knows what they are installing. Everyone makes improvements daily. Bathrooms are kept clean. Good neighbors take care of their customers' needs. Nothing, materials, trash, other items, hits the floor. Correctly sized inventory buffers for all materials are created and coordinated daily for just-in-time deliveries and scheduled deliveries. All cords are off the floor and managed in a remarkable way. Everything, including racks and painted pallets, is on wheels. All accessways are clear at all times. All workspaces are clean and organized, with a place for everything and everything in its place. Pole work behind you. Nothing is left behind. Areas are cleared and swept. Cultures of Takt. Culture is the common beliefs and behaviors of a group. These micro actions and beliefs drive the outcomes that determine the success of the team. There is a best-in-class culture that will support Takt. So what culture thrives with Takt? People thrive in a Takt system when they believe design is difficult and the team should make provisions to work past it. The team should schedule together and attempt to understand the whole plan. The team should take ownership in the whole schedule. Bringing up concerns and solutions is crucial. Trades should go to other trade partners to coordinate and solve problems, and only bring up problems to GC when necessary. The team should help keep other companies accountable. Trades will solve their own problems when possible. Learning lean practices is valuable. Keeping the project 100% clean all the time for crews and areas is the foundation for success. Treating other team members like customers and appreciating them is the only way to interact as partners. In following the project rules and requirements. People do not thrive in a Takt system when they bring their old, guarded, and siloed behaviors with them. A person in a Takt system needs to stop thinking that blaming everything on design and never learning from job to job is normal. They should schedule only their work and think nothing of what benefits the project. They don't need to understand the schedule, buy in, or use it. Complaining about everything is appropriate. Always going to the GC to coordinate work and expecting them to solve their problems is acceptable. It is only the GC's job to hold everyone accountable. Lean is a fad, and they only need to learn lean out of necessity. Cleanliness is not a priority. They can work like they are an independent company without respect for customer service. Rules can be broken and loopholes will be tolerated. Ultimately, systems implemented on-site must come with a culture, and no system will succeed unless it is accepted by the culture. That is why cultural creation is such an important consideration when implementing Takt or any other system. This shows why CPM is so hard to put in its place. The siloed, fearful, non-collaborative culture that we have been taught in schools and society strongly supports CPM because CPM is secretive, non-collaborative, and deceptive. It is the dark environment in which bad cultures can thrive. Takt only thrives in the light, in good cultures, where transparency and teamwork are important to the collective group. What supports Takt? Rules, routines, and discipline support any system we implement. Rules give us boundaries in which to work. Routines are the habit loops we have formed that are a part of our culture, the beliefs and micro actions of the group. Disciplines, or tactics, are the ways in which we work within our boundaries according to our culture. The tactics that follow improve the efficiency of the system and will support Takt in a remarkable way. A brief description seems appropriate. Kitting. The process of pre-coordinating, detailing, pre-cutting, and packaging all assemblies in the building, such as interior rooms, exterior panel sections, and other installations that need to be optimized to fit into the Takt time. This creates a stable environment where flow can be created. Trade partner buy-in. At every step in the process, trade partner buy-in is crucial where possible, especially the development of the plan. Proficient layout. Proficient layout seems like common sense, but it needs to be reinforced here because improper layout becomes the root cause for much of the variation we see on project sites. Remarkably, accurate layout and control support Takt because it prevents rework and interruptions. Building information modeling. BIM supports Takt because it enables the prefabrication of materials, material spools, and assemblies. Prefabrication. The genius of prefabrication is that it moves workers, material, inventory, and waste into more stable environments. Prefabrication also moves coordination and problem resolution early and ahead of the work in the field. This is the magic of the system. If we can't draw it, we can't build. And to prefabricate, we must draw it early, and therefore, building it is much like piecing together Legos or IKEA pieces on site. If prefabrication is like preparing Legos, then Takt is the enabling rhythm with which those Legos are pieced together. Buyout and contracts. In the United States and many other areas of the world, Takt is new, and therefore it must be clearly outlined in contracts. The Takt Plan, the use of Takt Plan, and the Integrated Control System should all be included in the contract. Early orientation meetings. When workers and foremen arrive on site, they need an effective orientation to ensure success. 90 minutes of onboarding will go a long way towards enabling people to interact with the system. This can be done with books, online courses, a PPT, or whatever way that allows the on-site team to interact and successfully anticipate expectations. Zero tolerance. There is no better phrase than zero tolerance to communicate intolerance for deviations from the system. Zero tolerance, when used inappropriately as a punishment system, has a convoluted meaning. What we mean by zero tolerance is intolerance for behaviors or conditions that deviate from the team's plan, which includes disrespect for people and resources. If the system is to succeed, a project cannot tolerate bad behaviors and conditions. Stability is contingent on rules, routines, and discipline. Zero tolerance is simply a discipline wherein leaders tolerate respectful environments only, and when they do not, circumstances are changed to ultimately respect the individual. It is not punishment. Clean environments. Everything thrives in a clean environment, especially Takt. There can be little or no flow when we do not have a clean environment. Just like any other successful environment, cleanliness must come first. Stabilized delivery systems. Delivery systems must be stabilized and controlled to ensure inventory buffers are right-sized and materials are brought out just in time. Contractor grading. When the performance of the general contractor and trade partners are graded in a non-subjective fashion, the system will be self-sustaining and will constantly improve.
Please join us next time in elevating the entire construction experience for workers, leaders, and companies coast to coast. If you're enjoying the show, please feel free to share with your construction colleagues and help us spread the word by rating, subscribing, and leaving a review on your preferred podcast listening platform. We really appreciate it. We'll catch you next time on the Elevate Construction Podcast.